Morning, this afternoon maybe for some of you. This lesson starts with a little matching activity, so open up the Word document that says water key terms. You will see the key terms up here and the definitions here. Just pop them in the right place. Okay, once you have done that, then open up the PowerPoint for today's lesson. You will find the answers on slide number 1, which I'm not going to show you now. But the aim of today's lesson is to have a look at global patterns and trends in the availability and consumption of water, including embedded water in food and in manufactured goods. Okay, so let's have a little look at this. So where is water? So traditionally you've probably thought about water in terms of the water cycle and the movement of water through that closed system. So we know that it's a closed system, which means that nothing ever leaves, it just sort of circles around in there. You may have seen a diagram similar to this before. So of all the water on Earth, 97% of it is salt water or saline and is held in the oceans and seas. Then there is 3%, which is actually fresh water. Now most of that is held in glaciers. Well, obviously that's reducing at the moment. A lot of it's underground in aquifers and underwater storage, and probably you might have heard the term the water table. So that's kind of the level of stored underground water in a specific place. And then only 1% of the fresh water on Earth is in our rivers and lakes. This is quite an important concept you need to understand, is this idea of virtual water. So although we traditionally think of water as being in rivers, lakes, seas, glaciers and all that sort of stuff, there's also water in everything that we use every day. So the stuff that we drink, we shower, we wash, but it's also in our products, so our clothes, our shoes, and in the food that we eat. And it's in all of the stuff that we buy and the energy that we use as well. The water footprint, so obviously last lesson we were looking at eco footprints. The water footprint tells us how much water is actually used to produce all of these things. And we each have a personal water footprint, which is related to what we eat, buy and use. And that can also vary according to where you live and also how you live, so your kind of consumption and your lifestyle. Just have a little look at this graph here. You can see the dark blue colours are places that have plenty of water. And as the blue colour starts to descend into a lighter colour, the light blue indicates countries that are vulnerable to water stress. Okay, so these two terms, water stress and water scarcity, are quite important ones to understand and to make sure that you use in your writing about this sort of thing as well. So the pattern that we can observe there in terms of nations that have a lot of water and the nation sort of moving towards vulnerability are mostly kind of our very northern hemisphere countries and very southern hemisphere countries, for obvious reasons because of the climate. And then in the middle section there you will see there are a number of countries that experience water stress and water scarcity. Okay, so those are the ones that are in the kind of yellowy, browny colours, and you can see that we live in an area of water scarcity. Now the concept of scarcity isn't necessarily related to the availability of water. For example, in a place that has no water but no people, there's no water scarcity. In a place that has no water and lots of people, there is water scarcity. So don't get caught out by that. I've seen a couple of questions in the past in the exam papers that have asked for kind of definitions of that, and people have got it wrong because they haven't understood that scarcity doesn't exist unless there's actually people there to experience it. So just keep that one in your mind. Okay, similar map here, very similar pattern, just different colours. We've got two different terms here. We've got a water surplus and we've got a water deficit. Okay, so you can see that there are areas which experience what's known as a water deficit. So they don't have enough water, but also that they are taking water from other areas potentially, or having to create their own water using quite energy intensive processes, like desalinization, which is where you take seawater and you pass it through loads of membranes to get rid of all the salt and the impurities and stuff like that. And then you've got fresh water. Usually doesn't taste very nice though, to be fair. So you can see these areas of deficit, quite often it's related to climate, but also to population, where you have a massive population that can also create a deficit. Okay, so the concept of a water footprint is made up of these three things. So we've got green water, so that's rainwater, which is incorporated into a product. Blue water, that is surface or groundwater, that is incorporated into a product. And grey water, so that is the water that is needed to assimilate any pollutants that are created during the process of production. Okay, so that's kind of before we sort of touched on the idea of externalities and negative externalities. This grey water is an externality, so something that's created as part of a process of production that isn't exactly what we desired, and it's not the actual product. Okay, so direct water footprint is the idea of just the physical water that we use in making a product, and the indirect stuff is all that other stuff that we just talked about. It's the stuff that's within the components of something. Right, so your first task, what you're going to need to do is download the Word document that is called Spearman's Rank. Okay, you're going to use these 15 countries on this graph here to do a statistical test. So the data that you've got here is their water footprint per country, and you are going to compare that to their HDI ranking, so their Human Development Index ranking. Okay, download the Word document. Okay, it looks like this. All right, and it talks you through it step by step what you need to do. All right, so Spearman's Rank is something that is one of the statistical tests that you might use in your internal assessment for geography. And it's a test of association. Basically, it's just looking at the relationship between two sets of data and trying to work out if there's a positive relationship between them or if there's a negative relationship, and indeed how strong is that relationship. Okay. When you do this, what you need to do is you need to start with a null hypothesis and try to disprove it. So the null hypothesis would be there is no relationship between variable A and B. So these variables would be there's no relationship between HDI and water footprint. I think probably you can potentially work out that there probably is quite a strong relationship between them already. Okay, so what you're going to do is you're going to create a table from the data. Now, do not miss the fact there is already a table here on the second page with all the countries inside. All you need to do is put in the data and work out the numbers. Okay, so what you're going to do is put in the data for water footprint and HDI, and once you have put all that data in, you're going to rank the two data sets. Okay, so the highest number will be ranked number 1, the next highest 2, the next highest 3, blah 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 blah, all the way down. If you get a tiered rank, so there's 2 the same, you should use the average rank. Okay, so for example, if there were 3 samples all with the same HDI ranked 6, you'd add them all together, okay, and then divide them by the number. So you've got 6, 7, 8 in this example, add them together makes 21, divide them by the number of samples, of which there are 3, and you end up with 7, which is obviously the middle one, but that's how you would calculate that, okay? And then you skip the other ranks, so you don't give them all 7 and then go on to 8, all right? You would skip 6 and 8, and then the next one you would go to is 9, so hopefully that makes sense. Given the difference, find the difference between the ranks of each of the pairs, okay, so that's your value for D here, the difference, and then square them, okay, so D squared in there, all right, and then using this formula, all right, you need to calculate the coefficient. So the answer should be somewhere between -1 and 1. Okay, so 1 being a perfect positive correlation and -1 being a perfect negative. All right. Then what we do is we check these values for their significance. Okay, so you need to use the significance table to do that. All right. Have a go at this. Look, it doesn't matter if you get it wrong. The idea is just to try it out and to practice doing these sorts of things. To be perfectly honest with you, I'm absolutely hopeless at maths, which most of you will know already. But I actually find doing this really easy because it's just a really simple procedure, and you come up with something that makes you look quite clever in internal assessments, and is actually not that difficult to do. So you will need to have a look at the significance table, which I will include in the documents for this lesson, and work out what it is. Then what you need to do is literally just comment on the significance down here, and then upload this document to, or if you want to write it in your notes or whatever, that's fine, upload it into the assignments, okay? Last thing to do today is there is a TED Talk here, okay? It's about 15 minutes long, the TED Talk, about 15 minutes long. Have a little watch of that, and just make some notes as you go along, just maybe pick out or just summarise. You don't need loads of info, but it's quite interesting and quite a good watch. So you just have a watch of that and then just spend maybe 5-10 minutes, depending on how much time you've got left, just making some notes, okay?